Alright, this is the third video in Chapter 1, Lesson 4, and in this video we're going to cover the OR inequalities. We already looked at the AND inequalities, and remember the AND inequalities, just for a quick review, you could either see the word AND in your inequality, or you had the X in between two values. X is greater than 4 and less than 12. Now, with the ORs, one of the things that we're going to notice with the ORs is you're going to see the word OR. So one of the characteristics is the word OR is in the inequality itself. So you're going to have something like X is greater than 12 or X is less than 7. Okay, so there's the word OR. You'll see the word OR. Okay, now unlike the ANDs, you'll never see it differently like this than this. You can't combine these into one thing. Okay, so you're always going to see them separated by the word OR. So that would be one of the differences between the AND or the OR. Make sure you know that. That might be a good quiz question for me to ask you. What's the difference between an AND inequality and an OR? An AND you can make into one, where you wouldn't have to use the word AND, but with an OR you can't do that. The second thing about an OR is that what that means is the value that you choose for X has to satisfy one of the equations, only one of the inequalities, excuse me, not equation, only one of the inequalities. It doesn't have to do both at the same time like the other one. I just need a number that's greater than 12 for this example, or a number that's less than 7. Either one will work. It doesn't have to be both, in fact, because you can't choose one number that is both. Okay, so those are the two characteristics of an OR. And again, we want to look at what that looks like graphically. So let's go ahead and graph this one here. So here I'm going to graph the first inequality. X is greater than 12. So here's 12. It's greater than, it's not included. Greater than would be up this way. Or if I graph the other side, X is less than 7. Let me use a different color here. So 7. So here's 7 and is less than, so those would be the numbers that go this way. Notice the difference in the graphs here between the ANDs. The AND had an intersection where these two could overlap. Okay, in this case, in 99% of the cases, not all the cases, but in most of your OR cases, your graph is going to look like this. You're going to have one arrow that points this way and one arrow that points this way. This is what an OR is generally going to look like. Now again, I'm saying 99% of the time, because there are some cases, which I'll talk about in a little bit, where it doesn't end up being that as an answer. Okay, but generally speaking, your ORs are going to look like this, and your ANDs are going to be intersecting. So let's go ahead and take a look at an example of an OR. Let's solve an OR and then go ahead and graph its solution. So let me go ahead and do this one. I have 4y minus 2 is greater than or equal to 14, or 3y minus 4 is less than or equal to negative 13. Okay, so I see the word OR, so in my mind right now I get a picture. It should look something like this when I'm done with the graph, generally speaking. So let's go ahead and solve these. So we solve these with our properties. So 4y is greater than or equal to 16 dividing by 4, so y is greater than or equal to 4. Or, and then we do 3y, we add 4 to both sides, that's negative 9. So y is less than negative 3. So y is greater than or equal to 4, or less than negative 3. Okay, so we're going to go ahead and graph these. So here's my origin. So we'll graph this one first. Y is greater than or equal to 4. So here's my 4. It's greater than or equal to, so that's a solid circle. Greater than is to the right. Okay, and then we have y is less than or negative 3. So here's my negative 3. It's less than, it's not included, so it's open circle. Less is to here, and so here's my graphical representation of this OR inequality. And again, it looks like something that I thought it should, with the ears going out this way or the things going out this way. All right, so that's an OR inequality. So, and there's usually, like we talked about, no intersection here, but there are some cases that we'll look at in just a moment. So before you do that though, I want you to go ahead in your homework and do numbers 22 and number 25. Okay, here's number 22, 4x less than 16 or 12x greater than 144. We solve the inequality. It's an OR. So I have x less than 4, that's represented by this, and then x greater than 12 here. And again, the graph of an OR generally looks like this. That's what it looks like. So I go ahead and I'm pretty sure of my answer. Okay, 24, or 25, excuse me. So I have 9x minus 9x less than or equal to negative 27, or 4x greater than or equal to 36. So I go ahead and I see that I have x is less than or equal to negative 3. It's a closed circle because it's equal to, and then x greater than 9. Okay.